Alright, so the most important thing about exponents tell us how many bases are being multiplied. The second most important thing about exponents is that exponents tell us how many bases are being multiplied. In other words, I'm trying to make this thing stick. Okay, I missed. Anyways, but here's the deal. If you have 3 and you raise it to the 4th power, the exponent tells us how many bases are multiplied. 3 times 3 times 3 times 3. If you keep that in mind, you don't really need formulas. You're better off as a mathematician to just simplify stuff down, and that is huge. How many things are you multiplying? Okay, so here we go. How many 10s are being multiplied? 2 there, 2 more there. Altogether 4 10s, and that's 10 to the 4th, that's 10,000. Now how about this? What's 10 cubed divided by 10 squared? Well, by golly, 10 cubed means 3 10s are being multiplied. This means 2 10s are being multiplied. So any one of these 10s divided by that equals 1. And this divided by this equals 1. 10 times 1 times 1 is 10, which is 10 to the 1st. So it's time for a new rule, the quotient rule. Quotient implying your dividing powers. So the quotient rule is just subtract the exponents. They keep track of how many things you're multiplying together. Subtract them and you'll get the right answer. So in this case, take the 5 minus the 3 to get 2 squared. That must be the final answer. But why does it work? Well, let's think this through. The product rule, when you multiply powers together, you add the exponents because there's 2 2's and there's 3 2's here, altogether 5 2's. But when you divide, you subtract them, you get 2 squared because 2 to the 6, it means that there's 6 2's multiplied together. 2 to the 4th, the exponent tells us how many 4's are being multiplied. This 2 divided by this 2 is 1. This divided by this is 1. That's 1. That's 1. So all you're left with is 2 2's. So it's 2 squared. Subtract the exponents. That's the trick. But if you just understand what the exponents are telling us, then you don't even need the trick. You just reason it through. Try some of these. Ten to the 6th. Subtract 10 to the 2nd. This one gets a little dicey. Don't be afraid of the variables. They're just numbers. There are 10 x's multiplied here. There are 4 x's being multiplied by here. If you can picture 4 of these x's, canceling out 4 of those, anything divided by itself is 1. This divided by itself is 1, and so on. So how many x's would be left on the top? 6, because 10 minus 4 is 6. So this would give you x to the 6th, y to the 9th, subtract those, and z to the 1st, 3 minus 2. So z to the 1st, or just leave it like this. This one's sneaky. Sometimes we get to subtracting exponents and we do something really dumb. We forget that 10 divided by 2 is 5. Don't just be subtracting everything. This is all division. 10 divided by 2 is 5. Now remember, the reason we subtract exponents like 5 minus 3 is to keep track of how many n's in this case are left to be multiplied by. 5 minus 3 is 2, so you're left with n squared on the top. Now this one's a little weird. M to the 4th, that's 4 m's. 1, 2, 3, 4. Is being divided by 1 m. So this 1 m will cancel with that 1 m, and you're left with m to the 3rd. So your final answer is 5m to the 3rd n squared. Now check this out. The shortcut is subtraction. 5 minus 3 is 2. Hey, if there's only 1 m here, give it an exponent. That's m to the 1st. And subtract 4 minus 1, and that gives you m to the 3rd. But please, just because you're busy subtracting the exponents, because you're keeping track of how many bases are left to be multiplied, do not do 10 minus 2. That's division. 10 divided by 2, it's 5. Can anyone explain why any number raised to the 0 power is worth 1? Pick me. Here's what you do. Check this out. Do we agree that 100 divided by 100 is 1? Hey, anything divided by itself is 1. We also agree that 10 to the 2nd divided by 10 to the 2nd is 1, because that's 100, that's 100. Anything divided by itself is 1. So we know this thing equals 1, but hold the phone. What's the little trick when you divide powers? You subtract the exponents. 2 minus 2 is 0. So this is also equal to 10 to the 0 power. So all of these things are equal to 1. Anything raised to the 0 power is equal to 1. Even a variable, x to the 5th, divided by x to the 5th. Hey, anything divided by itself is 1. And the trick of exponents, 5 minus 5 is 0. So this is equal to x to the 0, but it's got to be equal to 1. Inverses. In the world of math, let's not use the word reciprocal as much as we do. Let's try to use the word inverse. It is a more powerful, dynamic, mathematical term. So inverses are reciprocals. The inverse of 2/3 is 3/2. The inverse. The inverse of 8, well, put 8 over 1 and flip it. That's the inverse of 8. The inverse, here's the big thing now. The inverse of 10 squared is 1 over 10 squared. But we write it like this, 10 to the negative 2. But let's not call it 10 to the negative 2. It's really the inverse of 10 squared. So when we see a negative exponent, I'd really like it if we could say, hey, you know what? This thing should be read as the inverse of 10 squared. And we know it just means flip it, put 10 squared in the bottom of the fraction. So let's read this. Don't read it as 2 to the negative 3rd. Let's read it as the inverse of 2 cubed. And we'll show it as 1 over 2 cubed, because that's what the inverse means. This is 1 over 2 times 2 times 2, which is equal to 1/8. So 1/8 is the inverse of 2 cubed. This is the inverse of 5 squared. So we can show it like this, 1 over 5 squared, the inverse of 5 squared. But is there another reason why the inverse of 5 squared is written like this? Bet your sweet bippy, it's because of division. So check it out. If we have 5 to the 3rd divided by 5 to the 5th, we know that the trick is to subtract exponents, which gives us 5 to the negative 2. But let's think what this looks like. 5 to the 3rd. Remember, exponents tell you how many things are being multiplied. That's 5 to the 3rd divided by 5 to the 5th. Whoop, there it is. And we divide this 5 by this 5, we get 1. That gives us 1, and that gives us 1. So what are we left with? 1 over 5 times 5, which is 1 over 5 squared, which is the inverse of 5 squared. So we write it as the inverse of 5 squared. They all mean the same thing. Tie it all together. Understand exponents, and they aren't so tough. Remember, anything raised to the 0 is 1. Read this as the inverse of x to the n. And you can write it like that. And then here, we should write some of these with no exponents. Let's try this one. This one's weird. 1 divided by y to the 0. Hey, anything to the 0 power is 1. So this is just 1 divided by 1. By golly, that's 1. This guy, okay. X to the 7th, no problem. Y to the 0 is just 1, so we're going to multiply by 1. And then this is the inverse of z squared. So we multiply this by 1 over z squared. If we clean all that up, we get x to the 7th divided by z squared. It actually gets kind of fun. Now this one can hurt the brain a little bit. 1 over a to the negative 3. 1 over the inverse of a cubed. All right, I'm going to risk hurting your brain, but here it goes. Let's do this the long way, and then let's take a shortcut in the future. 1 divided by the inverse of a cubed means 1 divided by the inverse of a cubed. But if we look at this division bar, if we take 1 divided by this fraction, we can change this to 1 times the inverse of this, which is a cubed over 1. You might have heard copy dot flop or whatever like that. But this means 1 divided by 1 over a cubed. We can, when it comes to fractions, we can change to the opposite or the inverse function by changing this to the inverse under the operation. So it's this, which is just a cubed. That's our final answer. So, a little trick if you're ready for it. If you see a negative exponent, then you know that you're just taking the inverse of the positive power of that thing. So, if you have a to a negative exponent down here, it can show up being inverted. It can be a positive a cubed in the numerator. If that makes sense, you may need to practice that more. But look at this. This is the inverse of x to the 7th. So that means that that's the inverse of x to the 7th. That goes in the denominator. Is being divided by the inverse of y to the 6th. But the inverse can be popped to the other side of the vinculum, the fraction bar. So that becomes this. So any negative exponent can go to the opposite side, can be inverted. It's the inverse, can be inverted to the other side of the fraction bar. So keep all that in mind. I think we're good. Just remember, the most important thing about exponents, they tell us how many bases are being multiplied. Like 7 to the 4th, there's 4 7s being multiplied. And read this as the inverse of 7 to the 4th, and know that it means 1 over 7 to the 4th. And I think you'll do just fine.